This lesson is on the average rate of change. By the end of this lesson, you should be able to calculate the average rate of change, determine if a function is linear or not. When we model using functions, we are very often interested in the rate that the output is changing compared to the rate of the input. Exercise 1. The function f of x is shown graphed to the right. In part A, it asks us to evaluate each of the following based on the graph. So again, we have our function notation, so f of 0. So remember, 0 is your x value. So we go to where x is 0, we find the y value. So since there's no numbers on this graph, we assume they are counting by ones. So this is the ordered pair, 0, 1. So f of 0 equals 1. Then we go to f of 4, and again, 4 is your x value. And our answer is 4, 7. So f of 4 equals 7. So part B, find the change in the function delta f, so that means change in f, over each of the following domain intervals. Find this both by subtraction and show on the graph. So the first one says 0 to 4. So here's 0, here's 4. Subtraction. Basically, we are finding the difference in the y values. So we already did 0 and 4. So 0, 1. So 1 goes here. And 4 is 7. So the change in f is 7 minus 1, which is 6. So we know 4 is 7. So find 7. Which is 10, so the change in the function is 10 minus 7, which is 3. And then here, 7 we already know is 10, 13 is 15, so the change in f equals 15 minus 10, which is 5. Alright? So part C, why can't you simply compare the changes in f from part B to determine over which interval the function changes the fastest? So if we used our ruler and connected the dots, we just can't tell which one changes the fastest just by looking at these numbers. So what do we also need? We need horizontal and vertical distances, not just one. Okay, we need both. So now we're going to calculate the average rate of change for a function over each of the intervals and determine which interval has the greatest change. So to find the average rate of change, we need the horizontal and the vertical. So the average rate of change is the change in y over the change in x. So the change in y, we said, was 6, or 7 minus 1, and the change in x is 4 minus 0. So 6 over 4 is the same as 3 over 2. And we notice over 2. So now, can you try I and triple I? If not, you can start the video again. If you can, pause the video, try it on your own, and then press play. So the change from 4 to 7, we said was 3. And the change on the bottom is positive 3, which is 1. And if we look at our graph, we go up 1 over 1, up 1 over 1, up 1 over 1. Part triple I, 7 to 13, we found was 5. And 13 minus 7 is 6. And if we look over here, we go up 5 over 6. So using a straight edge, draw in lines whose slopes you found in part D. So average rate of change is the change in y over the change in x, which is the slope. And if you check your numbers against your graph, that's what you'll see. So from 0 to 4, we rose 3, ran 2, rose 3, ran 2. From 4 to 7, we went up 1 over 1, up 1 over 1, up 1 over 1. And from 7 to 13, we went up 5 and over 6. So the average rate of change gives a measurement of what property of the line? And your answer should be the steepness. It tells you which line is steeper. So the average rate of change is an exceptionally important concept in mathematics because it gives us a way to quantify how fast a function changes on average over a certain domain interval. Although we used its formula in the last exercise, we state it formally here. Change of f over change of x, which is the same as change of y over change of x. Change in the input is change in the output, or f of b minus f of a over b minus a. Consider the two functions f of x and g of x. Calculate the average rate of change for both functions over the following intervals. Do your work carefully and show the calculations that lead to your answers. So I will do part I, you will do double I as a try it on your own, and if you have questions you can ask in class. So we need, for f of x we'll do here, and then g of x we'll do here. So f of x, we have the change in y over the change in x. So what are the y values for -2 and 3? So -2 is 5 times -2 plus 7, which is -3, and 3 is 5 times 3 plus 7, which is 22. So we need the change in y. So we'll go 22 minus -3 over the change in x, 3 minus -2. And our answer is 25 over 5, which is 5. G of x, we have g of -2, which is 2 times -2 squared plus 1, and it's very, very, very important that you put this -2 in parentheses in the calculator also if you're using the calculator, which is 9. And then we have g of 3, which is 2 times 3 squared plus 1, which is 19. And then we'll do change in y over change in x. So change in y is 19 minus 9. Change in x is 3 minus -2. So we have 10 over 5, which is 2. So go ahead and try double I. Pause the video. So your answer for this one, for change in y over change in x, should have been 5. And this one for change of y over change of x should have been 12. Make sure you have the work to support those answers. If you need help, ask in class. So, the average rate of change for f was the same for both I and double I, but not the same for g. Why is that? If you think about the segments of the graph and the slopes, because that's what we found being the same, we know that I is linear, and, f of x is linear, and g of x is not linear, which we already knew because they gave us the equations, but we proved that by finding the slopes of two segments or two different domains. So that's how you can prove whether or not a function is linear or not, by taking two separate domains and finding the slopes. If they are the same, they are linear. If they are different, we know they're not linear. So in exercise 3, we're going to use the fact that we know this is linear to fill in the table. And I can do this a bunch of different ways. I can do it by longhand, or I can use my calculator. So first I'll show you longhand, then I'll show you the quick way on the calculator. So first I need to figure out what my slope is. So my change in y over my change in x. So my y values go from -5 minus 1 over 1 minus 5. So I have -6 over -4, which is the same as 3 over 2. So my slope is 3 over 2. I need to know what my y-intercept is. So my equation of a line, y equals mx plus b. I know what m is. It's 3 over 2. I know what x and y are, any point in this table. So I'm going to use the positives because I like positives better. So I'm going to use 5, 1. So x is 5, y is 1. I don't know what b is. So in my calculator, or in my brain, I do 3/2 of 5, and I get either 15 over 2 or 7.5. And then I subtract it over, so I end up with -13 over 2 equals my b value. So my equation is y equals 3 over 2x minus 13 over 2. Now I can use this x value, put it in here, it'll find the y value. So y equals 3 over 2 times 11 minus 13/2. And I get y to be 10. For the next one, I need the x value, so I put 22 in for y, 3/2 x minus 13/2. I'm going to add 13/2 over and then divide or multiply by 2/3. So I could divide by 3/2 or multiply by 2/3. And I get x to equal 19. And the last one is 45. So y equals 3 over 2 times 45 minus 13/2, and I end up with 61 as an answer. Now, that's a lot of algebra, and there is an easier way, so let's take out our calculators. So the first thing we're going to do is go home new, get a list and a spreadsheet. You're going to go up to box A and call that x. Then you have to go down, over, and up, call box B y. And all we're going to do is put in the x and the y values that we know. So we know 1 for x and 5 for x. And then we know y value of -5 and y value of 1. And all we're going to do is find a regression. Another word for regression is equations. We're going to find the equation of these 2 points. So we're going to hit the menu button. We're going to do statistics, stat calculations, and we're going to find the linear regression. It's a line. Up here we put x, here we put y, and then we click OK, and it tells us linear regression. The equation is mx plus b, our m value is 1.5, and our b value is -6.5. It found the equation for us. And the even better part is it's graphing it. So we're going to go home, and we're not going to do a new document because we want to keep that information. We're going to hit this graph that looks like a parabola down here. And notice it brings us to f of 2. So we're going to arrow up to f of 1, and we have to hit enter so it'll graph this. There's our line. Now we can go to the table, Control T, and look for those x values. So where is x 11? And what's the y value? 10. Now we're going to keep going because we're looking for the y value of 22. right there. The x value is 19. And then we're looking for the x value of 45 and the y value 61. I love the calculator. I think it makes the algebra visual, okay? So we found our equation of a line, we graphed the line, and we just found these points on the line. We didn't have to do all that tedious calculation. If you have questions or you want to go over this again, just ask in class. Good luck!